Okay, good morning. June 23rd. Today we will cover the final SQL PowerPoint, which I will now share and give you some time to finish up those other SQL exercises and get all caught up with everything. And if there's a few of you that are already caught up, so I've got some more stuff to mess with, and the more you are involved with SQL, I think the more interesting you'll find this. But it is, kind of extra additional supplemental material for those of you that are completely caught up. Some of y'all are knocking this out of the park, which is cool. This is, of the 4 cohorts, I gotta say, the 8 of you are, as a group, statistically speaking, more advanced than I've dealt with before. Kind of cool. Okay, so I call this one additional cool functionality because I couldn't think of any other place to put it. So there are some other constructs here, and I've gotten into the SQL tutorials since you guys are really asking great questions. I've gotten more into some of the tutorials and whatnot than I have in the past. And I'm learning a lot. I just really wish I could work with this stuff more in a real world setting. So the first additional cool functionality I wanted to talk about was a case statement. We have derived a column value in our select statement. By like using functions and arithmetic calculations. So a case statement will allow you to do that, that calculation, that derivation, based on conditions within your SQL query that allows you to do things that are fairly flexible and powerful if you didn't have this construct. It's allowing you to do stuff that I don't know how else you would do it if it wasn't for this syntax. There may be some other way to do it, but it sure makes it a whole lot more readable. So anyway, yeah, case statement goes through the conditions and returns a value just like a Python if elif else. It checks the condition just like the Python if, the very first leg of a conditional statement. If it satisfies that, it bombs out of the if elif else block. And then it goes down and it checks each elif as you go down. And once it satisfies one, it terminates that whole branch and goes on to the next thing. It never checks, like if one of the elifs is satisfied, it never checks the else. And then the else executes every time that none of the other ones are satisfied. So just, you got to bear that in mind, just like you would any other programming exercise. You can goof up the logic. I think I did that just yesterday of the case statement so that it doesn't do quite what you thought it was going to do. So yeah, that's how the case statement works. And then here's an example. So what we're doing here is selecting a column out of the table, course name, right? This is in our Northwoods database. So we're selecting the column name, and the case statement is another column name, is another column that you are deriving and naming with this as course length down here at the end of the case. And this is a very simple case statement. We'll do some that are a little more lengthy. So what this does is it selects the course name, and then it checks the credits column, and it says when it equals 4, then long course. And this is where you are assigning the value for that column inside of this case statement, which I wish Dexter was on here, because I'm curious if this would help kind of with his row num over construct that he has to do at work, where you prioritize things. You assign a priority based on a value, which I think this might be helpful in doing that. So anyway, so we'll plug this in to our SQL workbench. And I did a fair amount of goofing around with these. Oh, this is another thing I need to show before we're done, but I'm stealing my thunder here. Plug this in. So that's a straight cut and paste out of the PowerPoint. And you see, so we're not selecting course length. We could select, we could add course length. I'm sorry, credits. We're not selecting credits. So we could add that field that we're goofing around with in the case statement, but it's kind of redundant. You know what I mean? But I'm just showing you that it's working. For the courses with 3 credits, it creates this derived column and assigns a value inside of the case statement. And this case statement, and then and the when and then, when da-da-da, then da-da-da, that can be, you can have 30 of those if you need them. So there you go. There's a short case statement. Any of you guys using those at work already?
ECI, TS, one alert file, JHA, UAT, sprint planning, weekly amount. It's a little bit more advanced, but yes, sir, we're using it.
Was that Kevin?
Oh, this is Dexter.
Dexter, hey man.
Yes,
sorry, I'm looking at my PowerPoint. I'm not looking at who's in the course. Yeah, I was wondering if this would be helpful for you when you were talking about assigning a priority. Unfortunately, the MySQL doesn't appear to support that row number. Our version of MariaDB doesn't support that row num over construct that you were asking about. It supports it starting in like MariaDB 10 and MySQL 8, and I think we're on version 5. So I've asked my database guy, but I think I'm limited by cost. I think it costs more to host those on Amazon Web Services. But anyway, yeah, if you're looking at one column and trying to use some logic to derive another column based on that, categorize things, whatever, yeah, this comes in pretty handy. So let's see, next slide here. So yeah, in Workbench, double click on the North Wind schema, which is again our North Wind traders. This is one of many. You see this thing in different formats with slightly different column names, slightly different table names. So when you double click on Northwind, it makes it the active schema. And here's another case statement with we're concatenating the name into name. We're selecting company and job title, and then we're deriving a service level column based on the job title field. So we'll grab all of that, stick it into Workbench. And execute it. So we're seeing, if you're the owner, you get a priority. If you're a purchasing anything, that's why I'm using the substring function grabs the first 10 characters of a column. I could have also said when purchasing when job title like, and then used purchasing wildcard. Same result. So if you're a purchasing anything, you're urgent. Otherwise, you're routine. And I think there's only really one otherwise. Accounting assistant. Yeah, there's not an accounting manager, but you get the idea, right? You can assign that column's value based on any information in here. Okay. And I'm going to pop over to the W3 Schools website. In my coding stuff, SQL tutorials, W3 Schools, open a new tab. And get me a try it yourself window. And I'm not going to use that, but I wanted to, I kind of blasted past that in the SQL tutorial. If you would like to read their version of it in the case statement here, they give a good syntax, just like everything else. This is a great website, by the way. It's got exercises, a quiz, examples, and you can go through the tutorial from A to Z, and it goes through every one of these, absolutely every command in SQL and function in this version of MySQL. But yeah, here's the case statement. So this is giving you an example. So I modified this slightly. I'll click on it and bring it up. So what we're saying here is this. Remember, this Northwind database has products and shippers and suppliers and customers and categories. So it's a kind of like a e-commerce effort. So what we're doing is selecting order ID and quantity, and we're deriving a column called quantity text that we're deriving with a case statement that when quantity is greater than 30, we make that value the quantity is greater than 30. When it's equal to 30, the quantity is 30. Otherwise, which is of course going to be less than 30, correct? The quantity is under 30. So if we run that, I'm trying to remember if there was one that was exactly 30. There it goes. The quantity is 30. So there's that case statement. But I wanted to, mainly because of my buddy Seth teaching me that subqueries can be used everywhere, and that just really opened up my eyes. I'd only used them in the where clause. I wanted to do an aggregate function. I wanted to do a subquery in the case statement, and because I've been goofing around now that we've been talking about that. You can use a legal subquery virtually anywhere. You can put it. It can be part of your select statement. It can be part of your case. It can be part of your from, part of the where. It's yeah, it's definitely opened my eyes. So what I got here, let me punch it into the website. I think it'll come up a little clearer in a bigger font. So I modified this query, still a case statement, but I wanted to put in a subquery with an aggregate function, which returns, remember, an aggregate function returns a single value. So you can use it in this and it won't error. But what I'm doing here is I'm selecting or I'm using a case statement so that when the quantity is greater than, and then what I did was I used the aggregate function of average, which the average of quantity is like 23.73 or something like that. It's a floating point result, which I wanted an integer result. So I used the floor function to find the largest integer lower than what the average function was bringing back, which I think it's 23. But you know, I got that working, and then I inserted it into my case statement. So when quantity, really what this is saying in English, you know, is when quantity is greater than average, then the quantity is higher than average. When the quantity is less than average, then the quantity is lower than average. Else the quantity is exactly average. And I created that as quantity text. But yeah, you can use a select statement in at least the select, from, and where clause, and it works great. I'm trying to remember. There's a bunch of order details. There's 2,155 rows. When I ran this, I don't know that anything was average, which would have been handy to prove. I don't think, I'm trying to remember if and I will do that. Let's do that. Let's modify it. So I want order ID, quantity, and I want to change all this just to a where quantity equals all of that stuff. I'm going to have to move my from. Okay, so select order ID and quantity. I got to move that up. From order details, where the quantity is exactly the average. And I'm trying to remember if it might not have returned any rows. Yeah, arg. Ah, that's right. So then I went down another rabbit hole, and I'm trying to remember if I saved it. Oh, I might not have saved it. Doggone. So what I wound up doing was where quantity equals. I might have it in. No, I don't have it in Workbench. I did a query where it checked to see if the quantity was 3 below that average or 3 above that average, and that did return some rows. But you can make that logic as complex as you can. God doggone, I wished I would have saved that. I could have done it right here, but I didn't. Oh well. Any questions on that? Is anybody like really wishing I would recreate that query where it checks 3 below, a range of 6 quantities, you know, from 3 below average to 3 above average. Nobody's thinking, doggone, I wish you'd show me that. That sounds so interesting. Okay, I'll move on then. Okay, so that's the case. Any questions on how to use a case statement to derive a column? All righty. And then we've used this before, the union. The union operator basically stacks your query results, one atop the other. So they have to, the two queries that you are unioning, we unioned a left outer join and a right outer join to get basically all of the students and all of the faculty members. And we showed nulls where the students had not been assigned an advisor, and nulls where a faculty member was not an advisor, had not been assigned a student. So that's how we unioned those. But those two queries were the same number of columns and the same or very close data types. You know, there's like a couple of different floating point. There's floating point and fixed point. But as long as the database can make sense of it, it will stack those query results. And it maybe I catch this on the next one. Yeah. By default, it's distinct. It selects distinct rows, so you won't get duplicates. So like by chance, if you wanted a list of all the people and you had tables with multiple people names in it, a union like this one, and I'll cut and paste that. Do not forget to go back to North Woods. Double click on that one to get the right schema active. So what that'll do is select, it's not a join, right? You're not joining these tables and doing any kind of stuff like that. It's selecting every F underscore last from faculty, regardless. Union select every S underscore last from student, which are, you know, both string fields, and you get them stacked on top of each other because we're unioning them. So like if I comment out the bottom query, not underscore. Sorry about that. I tried to use an underscore instead of dash, which is the comment character in SQL. I don't know if we went over that. And you don't need that semicolon because we're only doing one command. It's optional. So there's your faculty members, returned 8 rows. And there's everybody, 8 rows, 16 rows. So you got, 4 students, 4 instructors, and you can do any legal query here. So you could do a case statement, you could do where, you could do whatever, group by union, anything, any, as long as the two queries that you are unioning don't break these rules, which is same number of columns and similar data types, compatible data types. Okay. And yeah, in my data set, I don't have duplicates, but union all would show those duplicates if you want duplicates. Okay, exists is kind of like an in operator. So over at W3 schools, what it does is it tests to see if a subquery returns anything, returns any row at all. So it's not like in, because in checks to see if like last name is in a group of last names that you query based on some result. Exists just means does this subquery satisfy any conditions whatsoever, um, uh, and if it returns a one row or more, it'll be true. So over here in W3 schools, let me get rid of that tab, go back to here, and there is the exists example. And of course, there's our syntax. So we're going to use the product and supplier. So supplier ID in our database is in the products table is a foreign key because it's a primary key in our suppliers table. Okay, so our subquery is going to return true because we're checking to see if they have a product that the price is less than $20 or euros. I'm not sure. So we'll run that. So these 24 people have a product that's less than $20. And of course, if you change the result, the criteria, there's only 11 that have something less than $10. How about less than $8? Do I hear 8? 6. There you go. So anyway, that's what the exist does. The exists runs this this query and checks to see if it's greater than 0. Okay. And then something else that can be handy is the limit operator. And this is a MySQL specific extension. Other databases use, I've seen row num, I've seen the keyword top, like you can say top 3 and it will only return 3 results. So this is the syntax for it. So let's see what I got in Workbench here. In Northwoods. And I'm going to use back to W3 schools. So I'm going to select, what do we got a bunch of? Select star from order details. So yeah, just wanted to see, it's not a great example, but you'd want to order this. Select star from order details. Order, capitalize that, order by, if we wanted to see like the top whatever 10, we would order by quantity, and then we would say limit 10. So if I run that, we should see, got to say descending. That's showing the bottom 10. But if we change the order to the top to large down to small, now we see the top 10 rows based on quantity. And yeah, that can come in handy. You can put that in a subquery. This limit clause, you could put in a subquery so that you're only comparing against the top 3 whatever, top 10 whatever. So that limit clause can be handy for picking off the lowest or highest in a range of values. I'm at 3. There you go. Another handy, cool functionality. Ooh, 9:16. I think I'm gonna. Yeah, let's take a short break. Let's take a like 10 minutes. 9:27. I'll come back, finish these last few slides, and then show you this supplemental cool stuff that you can do with Workbench. Okay. Back at 9:27. All right, welcome back. So it just had a little bit more to go over. And then I want to show you the supplemental extra credit stuff that I would encourage you to use. So yeah, back to using a subquery everywhere. There is a schema in Workbench called Schema 3 that is another sample Northwind database. It's very, very similar to the Northwind database. Schema 3. Customers, employees, offices, order details, orders, payments, product lines, products. So it's very similar, but the example I got from a tutorial site used that, so I went ahead and got it installed. I had to modify the create script a little bit. Okay. So when I cut and pasted, yeah, like usual, it doesn't like the quotes often when you cut and paste. Let me modify those first. Sure enough, that was what was wrong. So what this is doing is selecting 3 columns. Product code.
Hey, Don, we're only seeing your spreadsheet, or sorry, PowerPoint.
Oh, thanks. Stop share. I probably shared that instead of my whole screen, nothing but the screen. Sorry about that. Thanks for letting me know. Okay, yeah. So I took that. Go back to here. I took this query, and I'm going to run it against Schema 3, which is down here in our list of schemas underneath Northwoods and Northwind. Double click on that. It is a similar Northwind database that you can download as part of yet another tutorial site. God, there's so much free information out there. It's staggering. So anyway, what we're doing is selecting some columns here from products. You see there's a products table over here in schema 3. But we are using a subquery in the select statement. So I just wanted to give you an example of that. A subquery within here, within a normal query. That actually should belong there. And yep, and you run that and you see it. It does an aggregate function inside of a select statement, inside of the select statement, an aggregate subquery inside of your select statement. So anywhere in your SQL code that it makes sense logically, syntactically, you can use a subquery to derive a value. Very powerful. And yeah, the concat function is concating a couple of fields, or at the field plus this aggregate value times 100 and concating the percent sign. So you get this percentage of total units in stock. That's another feature of Workbench. It's not just for running queries. You can do database management. You click on the column name and it automatically sorts it regardless of the order by in your query. Then you just re-execute your query and it puts it back where in the order that your query had it. But yeah, these IDEs, integrated development environments, are pretty powerful. But like for Python, it's so much prettier. The output is in Jupyter Notebook than it is in Spider. Okay, and then another thing I stumbled on, which will be a good segue to another learning opportunity, is a very simple join sequence, syntax and clause that before this course and you guys, I was unfamiliar with, and that is join using instead of join on. Because in general you use on, and these words are coming from like a tutorial blog site, not from someone who's a much more expert programmer than I am. In general, we use on in MySQL. In joins, we use on in a set of columns. Using is useful when the tables have the exact same name, like the Northwoods database. And I think on day one, when we first started talking about relational database design, without even realizing that this syntax existed, I said just logically, it makes sense to use the same column name exactly in different tables if they are the same thing. You know what I mean? If it's a primary key, foreign key, if it's the same piece of data, it makes sense to use it to use the same column name. And then I stumbled into this and I thought, oh, look how elegant that is. So what I did was I reworded, let me pull it up real quick. I reworded no, that's not the right one. I reworded the worst query we had from last week. When I say worst, the most join conditions, multiple table. I think it was this one. Yeah. So where I had 3 tables joined, and I had old school where clause syntax. So I took this query and updated it using the join using syntax, which is right here. So look how much more elegant that is than that. And you've got both of these. Like I said, I uploaded this modified PowerPoint to the classroom this morning. So if you had downloaded it previously, you get rid of that one and download it from today if you want these code samples. So yeah, this is so much more elegant. And I got, oh, don't forget to double click on the Northwoods schema to make that the active schema. It doesn't have to be the active schema. If you, you can say schema.table.column as long on the same server, and it will work. But if you double click on the schema, you don't have to use that in your query syntax. Let's see here. So much more elegant. Join using. It's the same same results. I'll prove that. Get a new tab, punch that in. So much more readable and nice, but it's the same. Let me run it. Same result. You can see down in my output area here. So yeah, join using. Now, be honest. Was anybody thinking, gosh, Don, you could use join using during the whole class, or was this a useful tidbit?
I like your way better though, Christian.
Join using. Yeah, what it just goes through from student join enrollment using join, and then it joins the previous table using, and then it joins the previous table using. It like a chain. It links them together. Works pretty great. All right. Yeah, I learned something all the time. That's the cool thing about teaching. You know, you guys get to watch me struggle, but it sure keeps me in the books. Sure keeps me learning. And then last slide here, I mentioned this. We talked about it. I think I showed it, but this can be helpful for you to think about what is happening in memory when your SQL query executes. It goes out and gets the tables. It executes basically the from. It gets all of the entire tables that you are using and constructs this this joined up table in memory to start with. And that's what the database engine, the program that is running in the background that's managing your data, that's what it does is it creates this big matrix of the from clause, and then it filters out the rows in that big matrix by anything in any where clause, filters that stuff out. Then it does a group by, filters that stuff out by the having clause. And then the select clause goes through and grabs just the columns that you want to see after it has done all of that processing in memory. It grabs the columns and then it sorts them by the criteria in your order by clause. And then once it's got just the columns that you want in the order that you want them, it truncates the results based on a limit clause if you happen to put it in there. So you can, knowing what the database engine is doing can kind of help the way you think about your query that you're writing. So there you go. That's the order of operations. It's not the syntactic order, which I have a hard time I couldn't find one, because I know it's select, from, where, group by, having, order by, limit. I mean, I know that the order that they go in, but I couldn't find a cheat sheet that told me, like, if you say select name where name equals Smith from something, you get an error. You get, if you don't put those clauses in the right order, they it errors. So anyway, there you go. Order of operations. Any questions? Because where I'm going now is supplemental material, and I'm going to let you go for the rest of the day. Oop, I see something in the chat. Ah, okay.
I'm back now.
Cool. All right. Okay. Well, yeah, I mean, you can have a whole career writing SQL queries and doing and it's not just this SQL. There are database objects called, and it's right here in Workbench, called stored procedures, that are, I mean, you can write a procedure and then execute that procedure, kind of like functions, like the substring function or the type function, any of that stuff. You can write your own functions. When you have a database with many rows, you can improve performance by indexing on a column. That then anytime you have an index to a lot of data, it makes searching through that data exponentially faster. If you have 10 million rows in a database, and you want to search for the last name Smith, if that column is not indexed, it has to start at the top and go all the way down to the bottom and search every one of those 10 million rows for the last name Smith. But if you create an index on a large data set like that, it can use a much smarter search algorithm that will return your results, depending on the amount of data, in a hundredth of the time, 1,000th of the time, depending on how extensive your data set is. So there are other things you can do. There's a thing called a trigger, a database trigger. Here we go. Indexes. I don't really know why we have foreign keys in. Hang on. Let me collapse everything. Yes. So under Northwoods, you have 4 types of objects. All we've been dealing with are tables, which is your basic data structure. A view, the next thing down there, a view is, for all practical purposes, a subquery that exists, that persists. You can create a view to a table that selects only certain rows and filters. It selects only certain columns and filters certain rows. And then your database administrator can give permissions to the view, not to the underlying table, so that people in maybe your operations department can see stuff out of the HR database, but they can't see like the annual performance rating. They can only see the person's name and maybe their cubicle number or their telephone. So you create a view on the underlying data, and then give users permission to select data out of that view. which helps. And it can also be used so that you're not recoding the same subquery as a if you're writing reports or running reports or whatever. A view can save you time running the same query over and over again, or writing the same query over and over again. Stored procedures almost use a like a separate syntax. A stored procedure you can do almost like scripting Python level logic. Any of you guys work with stored procedures in the database that you work with? Because that's reaching the end of my practical experience. None of y'all write stored procedures?
No, sir, we don't write them, but we use them.
You use them. So when you're reading a stored procedure, Dexter, does it look exactly like a SQL statement, or do you see kind of other stuff, if then else and extensions to the language in there?
Well, our store procedure is for the morning load, and they have to run every couple minutes so we can see what's happening with the load. So it's a bunch of stuff. They got thin else, the rollover partition. It got a bunch of stuff.
Okay, I could be confusing the term stored procedure with the concept of procedural SQL, because even back in the 90s when I was working with this stuff hands-on, there was an extension to SQL called PL SQL that allowed you to do, if then else logic combined with SQL queries, and all in the same script. And I want to say with Microsoft, it's called T-SQL, transaction SQL, and it lets you do more than what we're doing. My point being, we've scratched the surface. There's a lot more that you can do with SQL. And like I said, it's its own thing. It's its own level of expertise. And there are queries that are just, for me, just staggeringly complex and powerful, that I think would be pretty tough to implement in something like Python. It does a lot for you. SQL is incredibly powerful. So that's all I wanted to say about that. Now, break. I want to talk about that additional database connection that I emailed you about, the one with the host name, and then you use guest as the username and relational as the password. I've got that. Let me close out. Right now I'm connected to our server. What is it? 100.26.226.59, I think. That is a virtual server running on Amazon Web Services under my buddy Justin Rowan's account. That's what we had been dealing with. That's where these schemas live, is on a MariaDB server in Amazon Web Services. This other one is something I ran into. Let me close this connection. So I'm no longer connected to our normal database. I created a connection by clicking on the plus sign here, and just like we made a connection to our normal class database. I created a connection. I call it MariaDB Northwind database because I found it searching for a MariaDB Northwind database to use for class stuff sometime back. But what I found, let me connect to it. And again, it's all the default parameters. You just use guest as the username and relational as the password. And Seth, I apologize. You're going to have the same exact firewall issues. Your security folks should really be troubleshooting this one, because we know for sure that the username and password works and all that. So anyway, what we have here is a bunch of 83, I think it is, sample databases, open source, public databases hosted by, I didn't look it up, this college that we're connected to. And these are all schema, just like Northwoods and Northwind and Schema 3 that we were dealing with on that other server. And for instance, and I'm giving this to you guys for like the rest of today. If you're all caught up, I've got some problems that you can work on if you choose to. But for all of you, this is a good resource for your for your future learning. Like, for example, the Chinook database is one that is used. Seth, I want to say it's a Postgres. It's built into the Postgres database. These are all in MariaDB, so they work on MySQL. But this Chinook database is a I want to say it's an online, like iTunes. It mimics the iTunes directory. Like, for example, let's columns in the album directory. So let's see, that's our select star from, and it's case sensitive, album, semicolon by force of habit. For those about to rock, we salute you. So there's the title of a song on an album ID. We got to order that by album ID. Hang on. Order by album ID. No, oh yeah, that's right. Yeah. For those about to rock, we salute you was an album. That was their second one after Bon Scott died. Never mind. Anyway. So yeah, you've got this Chinook database, which is you'll see tutorial sites that use the Chinook database. There were some other ones in here that I had seen elsewhere. Let me go down to it. Oh, there's some Mongo. I believe I thought I saw some Mongo. Maybe not. There's a Northwind database. Sure enough, there's another version of the Northwind database. Not necessarily, you see this implemented many different ways. Northwind is kind of one of those things that just went nuts as far as tutorial sites and learning SQL or for a sample database. But the one I wanted to show you comes with MySQL, and it's called Sequila. And it is, double click on it. It is like an IMDb style database. It's got actors and films and directors, I think. Actually, I think this might be the rent. Yeah, this is a video store, like renting DVDs. So you've got like our staff of our rental store. You've got film names, film categories. It seemed like it had other roles inside of the film, but anyway, Sequila, it's the kind of the sample database for MySQL or MariaDB. So that's how you get to that. And there's, like I said, I think there's 83 of them in here. the database for that is in my coding stuff, SQL tutorials. Nope, down here. Relational data sets in MariaDB. And you get a description of them all. Yeah, 83 of them. And I want to say one of them is Walmart. And it sounds like, not to encourage anyone to look for work, but it sounds like it's an online Walmart challenges participants. This is probably something off of, not Zillow, that's Kaggle. Kaggle is like a public demonstration competition data analysis, data science website. That's what this sounds like, is a Kaggle challenge. Walmart challenges participants to accurately predict the sales of 111 potentially weather sensitive products at 45 of their retail locations. So this is a limited data set. So if I go back over to Workbench, it should say Walmart. Walmart. There you go. And there's the tables. Key station train weather. What's the difference between it and Walmart 2014? Feature stores train. Huh. Well, there you go. Not a whole lot of data to dork around with. So that's what attracted me to Sequila. If you're going to spend a couple hours goofing around with SQL this afternoon, this is the database. This is where you get to it. The supplemental exercises are with answers. That's the other thing, is you don't need me to grade anything. Not all the answers are right. I was going through them and checking stuff. But if I go to coding stuff, SQL tutorials, Sequila queries exercise, I will put this in the chat if you're interested. And you see the answers are down here in a SQL script. But here are some, you don't have to download the schema and data scripts. We've already got that in our server. So I'll post this URL in the chat to everyone. Here's one. So it's got, yeah, just some sample brain teasers, whatever, and then the solutions to them are in here. And this is the website where I found the join using, and I thought, hey, that's awesome. So I learned from this site. And the other one that I have is in SQL tutorials, SQL example work using Sequila. So here we have the challenge and the code. So if they're doing something interesting here, and you want to see what that code looks like, you can run it in Workbench. And there's quite a few of those. Down. So anyway, like I said, a supplemental learning resource for those of you that would benefit from that. And let me put that in the chat. Okay, so both of those URLs are in the chat if you just want to click on them and get them up and running. While I ask if there's any questions or discussion about SQL before we kind of move on. We'll use it again in Python. We'll run a query and manipulate the results of that query in a data frame. and draw some line charts, pie charts, and scatter diagrams, scatter plot. Any questions? Okay. Do your very best to get caught up, please. I think I'm more or less caught up. If I'm not, I will be soon. Some of y'all are, like I said, are knocking this out of the park, and other folks can use a little bit of time, and that's okay. If you have any questions, like on that Sequila thing, if you can't get something to run and you want to email me your code, instead of doing a screenshot, actually email me the actual code so that I can punch it in and run it.
All right.
Cool.
Yes, sir.
Kevin, you good?
Yep.
Edgar?
Yeah, I think I'm good.
Okay. Like I said, everybody get caught up, and holler at me if you need anything. Email works best. If I don't answer it pretty quickly, shoot me a text. And I will see everybody Tuesday morning for more Python, getting back into the Python. Okay.
Yes, sir.
Have a good weekend, everybody.
You too.
Thank you. Have a good weekend.